Hello everyone, this is Mr. McMillan, and I'm here with instructional videos slash answer key to the laws of detachment and syllogism worksheet that I asked you guys to do. So this is what we covered in class, and the main thing is I wanted to make sure that everybody understood how to use detachment and syllogism in order to determine whether a conclusion would be valid. And the main thing we're going to make sure we do is if we're having trouble just looking at it to do it, we're going to put all of our statements into symbols, okay? And then from our symbols, we can use the properties for the laws of detachment and syllogism and then go from there. So let's look at number one. It says, if Alex spends more than $150 today, he will overdraw his bank account. Alex is buying a watch this afternoon for $175. So first thing is we're going to put it in symbolic form. So remember, you have P, Q, R, so on and so forth. P is always going to be the hypothesis of your first if-then statement. So in this case, the hypothesis for our first if-then statement is Alex spends more than $150 today. Okay. The next statement will be Q in that if-then statement. So that means that he will overdraw his bank account will be Q. Now with this statement here, this is not an if-then statement. It's just a regular statement. So it says Alex is buying a watch this afternoon for $175. So what you want to determine is which one does it relate to? Does it relate to P or does it relate to Q? Well, it says he's buying a watch for $175. That would mean that he's spending money. So P deals with spending money. And this says that P says spends more than 150. 175 is more than 150, so we can say this is statement P. Now we're going to write this in column format. So our first one is an if-then statement. P implies Q. And then our second statement will be P. And since we only have one if-then statement, we are going to say that we have a possible case to use the law of detachment. Remember, law of detachment uses one if-then statement, and law of syllogism uses two if-then statements. So let's look here. In order for the law of detachment to work, you need to have a true hypothesis, and you can conclude that your conclusion is true as well. So let's look here. P is our hypothesis. In our second statement here, it says P is true. So when it just says P here, that means P is true. So the hypothesis is true. Since the hypothesis is true, we can say that Q is true. Therefore, Q is true. And this would work by the law of detachment. Now we're just going to translate our symbols back to English. So this symbol, the three dots in a triangle, means therefore. And then Q, we said, is he will overdraw his bank account. So therefore, Alex will overdraw his bank account. And as we said, this would be the law of detachment. So the important thing here is the law of detachment only works in the forward direction. This statement has to match exactly what this is. So it doesn't matter if there's a not here or whatever else. It has to match exactly, okay? If it's even slightly different, it doesn't work. The law of detachment also does not work backwards, okay? So let's look at number two. It says, if the team won yesterday's game, I will wear purple socks to school tomorrow. I wore purple socks to school. So again, we're going to label these with our symbols. So if the team won yesterday's game, we're going to label that with P. And I will wear purple socks to school tomorrow. We're going to label that with Q. And then here it says, I wore purple socks to school. And which one does that relate to? Does it relate to P or does it relate to Q? Well, Q talks about wearing purple socks, and these are the same, so that would be Q. So we have P implies Q, Q. Can we make a conclusion based on that? So again, we have one if-then statement. So we are trying to see if we can conclude anything by the law of detachment. Now remember, the law of detachment only moves in the forward direction. This means your hypothesis has to be true in order for you to be able to conclude anything. And in this case, Q is not our hypothesis. Q is our conclusion. So this means that we're trying to work backwards, and that doesn't work. So we would say that this has no conclusion, and the law is invalid. So the reason why that is, it's very similar to when you talk about hypothesis and conclusion and results and everything else in science, right? If you have an experiment planned, you start out with a hypothesis, right? You make an educated guess based on what you think will happen, okay? And then you run your experiment and everything else, and then you get a conclusion, okay? And that conclusion might be what you expected, or it might not be what you expected. But regardless, the conclusion that you reach will be the true conclusion that you reach. But just like when you do your hypothesis, just because you see your conclusion is met does not mean that your hypothesis is what caused it, right? That's why in science, you constantly go through the scientific method. It's not just a one and done thing. It's a constant refinement of that hypothesis to make sure the conclusion works. So just because the conclusion's true doesn't mean you can assume that your hypothesis was true, okay? All right, let's look at number 3. Number 3 says, if two adjacent angles form a linear pair, then the sum of their measures is 180 degrees. If the sum of the measures of two angles is 180 degrees, then the angles are supplementary. So what we want to do here, we're going to put our symbols in. So we have two adjacent angles, form a linear pair. That'll be P. The sum of their measures is 180, will be Q. Here it says if the sum of the measures of two angles is 180 degrees. Well, that lines up with Q. So we're going to label it with Q again. Then the angles are supplementary. Well, neither P nor Q talk about angles being supplementary. Not with that word anyway. So that's R. So now we write this out in column format. We get P implies Q and Q implies R. So we have two if-then statements. And when you have two if-then statements, what you're looking for is to use the law of syllogism if you can. And the law of syllogism basically requires that your diagonals match. So when you have it like this, one of your diagonals needs to match in order to make a conclusion. And as we can see here, this Q diagonal here is the one that matches up. So we can cancel those out, and we can say that therefore, on the left side, P is left, implies, and then on the right side is R. So we can say therefore P implies R. So writing that out into words, that would be therefore, if two adjacent angles form a linear pair, then, and then we do R, the angles are supplementary. Okay. And that would be the law of syllogism. All right, number 4. Number 4 says if two angles are both right angles, then they are congruent to one another. Angle B and angle C are right angles. So two angles are both right angles. That would be P. They are congruent to one another. That would be Q. And then here it says angle B and angle C are right angles. Now, here it's talking about two angles that are right angles, and that would match up with P. Even though it's not worded the same, it still means the same. So this is P. So we have P implies Q and then P. Can we draw a conclusion from this statement, or from these two statements? And so since we only have one if-then statement, we're looking to see if we can use the law of detachment. So we have to see, is our hypothesis the one that's true, or is it the conclusion or something else? And if we look here, P is our hypothesis, P is the one that's true. So we can conclude that therefore Q is true because it works forwards. So writing that out, we would say therefore angles B and C are congruent to one another. And the law would be detachment. All right, number 5, if the tooth fairy visits, my sister does not cry. The tooth fairy did not visit. So can we reach a conclusion here? So the tooth fairy visits, we're going to label that as P. My sister does not cry, we're going to label that with Q. And then this one says the tooth fairy did not visit. Now, the important thing here is it says the tooth fairy did not visit, but it still talks about a visiting tooth fairy. So that is related to P. But is this the exact same as what P is, or is it the opposite? And if we look here, the word not is not present in the initial one, so this would be not P. So we have P implies Q, and then we have not P. So remember, one if-then statement, you're using detachment. So you have to make sure that your hypothesis is true. Well, here it doesn't say the hypothesis is true. It says that the opposite of the hypothesis is true. So we cannot use this to form a conclusion. So this would be no conclusion, and the law would be invalid. All right, number 6. And a good thing to do is, try these problems out on your own while we're doing these. We will be skipping a couple just because they're not really related to what we need. But, try them on your own and see, if you can manage it with the way we've done it. So this one says, if a figure is a parallelogram, then it is a quadrilateral. If a figure is a rhombus, then it's a parallelogram. So we're going to label a figure as a parallelogram with P. It is a quadrilateral with Q. Then it says if a figure is a rhombus. Now, this one said parallelogram, this one said quadrilateral. Rhombus is different, so that will be R. And then it is a parallelogram, that's P again. All right, now we list these out. P implies Q, R implies P. And since we have two if-then statements, we need to see if the diagonals will match. So in this one, do the diagonals match? You should see that we have a diagonal with P on both. We have, or P on that diagonal. So we can mark those out. And so we can conclude, therefore, R implies Q. So we write therefore. Now R says a figure is a rhombus, and it says then it is a quadrilateral. So you could write this simply as, therefore, a rhombus is a quadrilateral. You could also write it with the if-then statement. This means the exact same thing. And the law would be syllogism. Okay. Number 7, we're going to skip over. So we're going to look at number 8 now. So number 8, if a figure has 3 sides, then it is a triangle. If a figure is a triangle, then it has 3 angles. So a figure has 3 sides, we're going to say that's P. It is a triangle, will be Q. This says a figure is a triangle again, so that's Q. And then it has 3 angles. That is different from 3 sides or a triangle, so this is R. So we have P implies Q. Q implies R. You have 2 if-then statements. So you're looking to see if the diagonals match. And in this case, you see that the Q's match. So they mark out. And that leaves us with, therefore, P implies R. So we would write, therefore, if, and then P is a figure has 3 sides. Then R, which it has 3 angles. And the law would be syllogism. All right, number 9. Number 9 is probably one of the trickiest of the bunch. And that's because at first glance, this looks completely different from the other ones. And it's because it's worded differently. So first off, it says vertical angles are always congruent, and then congruent angles always have equal measure. So the key thing here is there are actually if-then statements hiding in these sentences. We can make one that has the exact same meaning. So it says vertical angles are always congruent. So the subject is vertical angles. So if 2 angles are vertical, then they are congruent. Likewise, it says congruent angles always have equal measures. So the subject is congruent angles. So if angles are congruent, then they have equal measure. Okay. So symbolically, 2 angles are vertical would be P. Q would be they are congruent. Angles are congruent. Again, that would be Q. And then they have equal measure would be R. So we have P implies Q. Q implies R. The diagonals match. So that means that we have P implies R as our conclusion. So therefore, if, well, you could write it as this. You could say if 2 angles are vertical, then they have equal measure. But you could also say, therefore, vertical angles always have equal measure. And that would be the law of syllogism. Okay. All right. We're going to skip number 10. And we're going to move on to number 11. So number 11 says, if a quadrilateral is a rhombus, then it is a square. If a quadrilateral is a rhombus, then its opposite angles are congruent. So Symbolically, we're going to say that a quadrilateral is a rhombus is P. It is a square would be Q. A quadrilateral is a rhombus. Well, that's the same thing as P. And then it says its opposite angles are congruent. That's different from the other two, so that would be R. Writing this out in column notation, we get P implies Q and P implies R. Now with this, remember, you have two if-then statements, so you need to make sure that your diagonals are matching. And do your diagonals match in this problem? Well, we have a P and an R on this diagonal and a P and a Q on this diagonal, so they don't match. So the diagonals don't match. So that means that this would be no conclusion and the law would be invalid. Okay. Number 12, if a triangle is isosceles and it has two congruent sides, triangle DEF is isosceles. So symbolically, we're going to say a triangle is isosceles is P. It has two congruent sides is Q. And then triangle DEF is isosceles. Well, that's what P says, so we're going to label it with that. So we have P implies Q and P. We only have one if-then statement this time, so we're going to be looking to see if we can use the law of detachment. And the law of detachment states that the hypothesis needs to be true in order to show that the conclusion is true. So here our hypothesis is P. P is our statement that's said to be true. Therefore, this works because we can work forward. So we can say, therefore, Q is true. And if we translate that to sentences, we get, therefore, triangle DEF has two congruent sides. And that would be the law of detachment. Okay. Number 13, if a line bisects a line segment, then it divides the line segment into two congruent segments. If two segments are congruent, then the segments are equal in measure. So a line bisects a line segment is P. It divides the line segment into two congruent segments is Q. If two segments are congruent, now that doesn't look the same as what Q is, but it still talks about two congruent segments. So that's going to be Q. And then it says the segments are equal in measure. That is going to be R. So we have P implies Q, Q implies R. Do your diagonals match here since we have two if-then statements? The answer is yes, these Q's match. So we can say, therefore, P implies R is true. So our conclusion is, therefore, if a line bisects a line segment, then the segments are equal in measure. And our law here, our law here would be syllogism. Okay, we're going to skip number 14 and we'll go on to 15. 15 says, if it is raining outside, then I will take my umbrella. It is raining outside. So P will be, it is raining outside. Q will be, I will take my umbrella. And then it says, it is raining outside, so that would be P again. So we have P implies Q and P. We have one if-then statement. So we're looking to see if we can use the law of detachment. And the law of detachment here says that the hypothesis needs to be true. In this case, the hypothesis is true. So we can conclude that therefore Q is true. So therefore, I will take my umbrella. And that will be by the law of detachment. Okay. Now there is one law that we didn't really do in these, and that is the law of contrapositive. What the law of contrapositive states is that if you have an original statement, the contrapositive is also true if the original statement is true. Okay. So for instance, we say that here, if it is raining outside, then I will take my umbrella. The contrapositive would be, if I do not take my umbrella, then it is not raining outside, and that would also be true. Okay, so just keep that in mind. All right, numbers 16, 18, and 19, we're going to skip over 17. We're going to see if these are valid, and if they are, by what law. So number 16, it says given not R implies S, and not R are true, therefore S is true. So does this work? Well, we have one if-then statement, so we're looking to see if detachment works. And we see here that we have not R is our hypothesis, and it says that not R is true. Then it concludes that S is true, which is our conclusion. So yes, this is valid by the law of detachment. Number 18, given P implies not R, and P implies S, therefore not R implies S. So we're going to look at these initial two if-then statements, and we want to see if their diagonals match. We're not even going to worry about the conclusion at this moment. So do the diagonals match? And the answer is no, the diagonals do not match. So we could not even make a conclusion here. So that means this one's definitely not valid. And then number 19, it says given P implies Q, R implies S, and Q implies R. So I'm going to write those out. And then it says therefore P implies S is true. So our conclusion says P implies S. Okay, so we're going to see if we have a path that goes straight from P to S. So we start out at P and it goes to Q. And we go back over to the left and it says Q goes to R. And then it says R goes to S. So by default, we say that P can go to S. So this would be valid. And we use the law of syllogism for that. And 20 and 21 are kind of just a review of a couple things that we did just to kind of keep keep on top of everything. Number 20 says identify the inverse, converse, and contrapositive of the following statement. Write your answers on the lines provided. And the statement is, if it is not snowing outside, then we will play baseball. So let's look at the first one. If we do not play baseball, then it is snowing outside. Is that the converse, inverse, or the contrapositive? Well, let's see what we did to the original statement. So if we do not play baseball, that is the opposite of our conclusion. So the opposite of our conclusions come first. And here's a good way to do it. P implies Q. So here we did not Q implies, and then it says it is snowing outside. And it is snowing outside is the opposite of P. And if you look here, those would be the contrapositive. Because what we did there was we switched and negated. So we did both. So remember, contrapositive, you do both. All right, next up, if we play baseball, then it is not snowing outside. So if we play baseball, that's Q. It is not snowing outside, that is P. So all we did here was just switch their order. So that means we did the converse. So switch only. Then our third one, if it is snowing outside, then we will not play baseball. It is snowing outside is the opposite of P. We will not play baseball is the opposite of Q. So not P implies not Q. All we did was negate, so that would be our inverse. And number 21, it says let P be an equation is of the form y equals 8x squared plus bx plus c, and let Q be its graph is not a line. Which of the following is the symbolic representation of the argument given below? So if you look at your answer choices, all of them have P implies Q from the start. Okay, they all have P implies Q from the start. So we're going to look at our second line here. The second line says the graph is a line. Now, which one talks about the graph being a line? Well, that would be Q, but Q says its graph is not a line. So Q here, that's the opposite. So this would be not Q. And if you look at your answer choices, the only one that has not Q in the second spot is C. And you can confirm that by the fact that this would be, the equation is not of the form, that would be the opposite of what P is. Okay. So that's this worksheet completely covered. I hope that this helped you understand from these practice problems. I do hope that it cleared up some of the confusion. If it did not, you can always email me and let me know, and I'll, do what I can to work with you as far as getting those all done. Okay. I do have a test review that is posted that I would like you to work on. And so work on that. An answer key will be posted to that before I post the test for it. And the test review is on the laws of logic as well as the stuff we did at the beginning of it, like the symbols and the converse, inverse, all that stuff. Okay? So thanks, guys. I will see you in the next video.